Welcome to today's Michigan Engineering DEI lecture. I'm Herbert Winful, the Joseph E. Ananpuro Professor of Electrical Engineering, Arthur F. Thurnau Professor, and University Diversity and Social Transformation Professor. The DEI lecture series is an important element of our People First Engineering and our launch of DEI 2.0. And we thank you for attending today. We appreciate you being part of learning and growing together as a community. It is my great pleasure to introduce our speaker for today's DEI lecture. Scott Page serves as the John Seeley Brown Distinguished University Professor of Complexity, Social Science, and Management at the University of Michigan, and the Williamson Family Professor of Business Administration, Professor of Management and Organizations in the Stephen Ross School of Business, as well as Professor of Political Science, Professor of Complex Systems, and Professor of Economics in LSNA. Scott's research focuses on the function of diversity in complex social systems, the potential for collective intelligence, and the design of institutions for meeting the challenges of a complex world. Please welcome Scott Page.
Thank you, Herbert. It's great to be here, and it's fabulous to be speaking to people in engineering. I kind of wish I were there in person, but this is kind of how the world works now. So what I want to do is I want to just spend 30 minutes or so talking about kind of some of the science of diversity from the perspective of someone who studies collective intelligence. And I'll kind of unpack what I mean as we kind of go along. But the idea here is to think about the challenges that we face as a society are complex, right? I'm a professor of complex systems. And how is it that diversity, and why is it that diversity is so important as we try and confront those complex challenges? So let me share my screen and present some slides. So the title of this talk is Diversity, Teams, and Collective Intelligence. And the kind of core themes I want to get across here is that most good science today, and most problem solving, most prediction, most of the things we do is done in teams. Those teams are diverse, and diverse teams have this incredible potential to produce collective intelligence. And so today, if we look at something like the Sustainable Development Goals, if we look at sort of not only having economic prosperity, but reducing poverty, hunger, taking care of the environment, we're operating in this 17-dimensional world, right? And so when you're trying to solve 17 problems at the same time, that's going to be incredibly complex because they're all interdependent. And you need lots of sets of people with different backgrounds, training, experience, concerns to make progress on those. So today was kind of like any other day for me as someone who studies collective intelligence, complexity, diversity, and that like I, go to the web to see what people have published. And here's a new paper that came out by Ihad Rahan and his team at one of the Max Plancks in Germany. And it's basically saying, look, if you've got these tasks, I realize this is a very complicated graph. If you've got a bunch of tasks, you can think of what's the complexity of that task and how much diversity do you have? And what you see from this paper, which is something that's also been shown in many other papers, is that when the problems are complex is when you really need diversity. So this is kind of a standard takeaway. And I often refer to this as kind of like a green eggs and ham result, right? In the sense it's true on a tree, it's true on a plane, it's true on a graph. So that particular paper looks at a specific class of things, which are problem solving on networks. But that same idea is true across so many other domains that once the problem becomes complex, even though our natural inclination would be, this is when we need, quote unquote, the smart people, the answer is what we really need on complex problems is intelligent, motivated, diverse people to make progress. So let me give an outline of kind of like where I want to go. I want to sort of talk about what we mean by collective intelligence and how we build it. Then I want to give just a brief overview on team science, some data and some logic. And then we'll talk about some actions we can take. So how is it as teams, as leaders, as groups, as staff, as faculty, as students, how do we actually leverage and harness our diversity on these tasks? Okay, so let's talk about building collective intelligence. What do we mean? It's like I'm teaching an undergraduate class. got some engineering students in it, which is great, on collective intelligence. And we really mean two things. One is when the team is just kind of better than its best or its average member, right? So it's kind of super additive. So the team is just better at doing something than the people in it. And then the second thing we mean is sometimes a team has qualitatively distinct functionalities than its members. So if you think of like an ant colony, the individual ants can't do very much, but the colony of ants can do lots of things. Or if you think of a brain, right, individual neurons have limited capabilities, right? They have chemical and electrical inputs and outputs, but the collection of neurons is us, right? And so that would be a case where there's a qualitatively different functionality. So when we think about diversity in teams, a lot of the research is on, including that paper I showed you before, is on super additivity. It's sort of saying, look, teams are better at predicting, they're better at problem solving, they're better at generating ideas, they're better at logical reasoning, and teams become even better than individuals when the problems get harder, when they get more complex. But there's also a sense in which when you think about like consciousness, ants and bee colonies, soccer teams, jazz quartets, even really good administrations, right? Or somebody, even think of somebody like running a particle accelerator or building a ship, right? There's a sense in which there's an emergent knowledge, wisdom, capability that does not exist within any one person, right? So, you know, we have a fantastic naval engineering department here at Michigan, but no one in that department could build a ship by themselves. Instead, there's like going to be teams of engineers and designers that have this emergent capability, which is to build a ship. Okay, so when we think about teams operating in complex systems, we want to think about them being diverse members. We want their actions to be interdependent, and they're responding to kind of local information as well as global information, and they're constantly adapting, right? So that's why we want to take this complex systems perspective on teams as opposed to sort of an equilibrium perspective. We want to think about people constantly learning, churning, thinking, adapting, classifying. Now, when you look across literally hundreds of thousands of teams and ask how do they perform, one of the things you find is that team performance is not normal. What do I mean by that? I mean that in a scientific sense. So statistically, we describe a distribution as a normal distribution if it looks like a nice bell curve, right? And you get bell curves if things are additive, right? So if I'm adding things up or averaging things, I get a bell curve. If you look at team performance, and this is from a paper looking at over 100,000 teams, you see this kind of long tail. So what you see, again, in this next picture, like the orange curve on the top is a normal bell curve. What you see from teams is something between kind of an exponential curve and a power law curve. What does that mean exactly? Well, those numbers by zero mean that like most teams are just kind of like okay. But then there's some teams that are just spectacular. So there's this huge right tail. So, you know, so if you think of human heights, people are between like, 5'3" and 6'9", almost everybody. If you think of teams, you want to think of there's teams that are 10,000 feet tall. There's amazing teams. And when you look at those amazing teams, what we're going to see is they tend to be diverse. Now, the challenging thing, though, when we look at the worst teams, they're also diverse. And so that's why when we talk about diversity 2.0, when we talk about culture, that sort of thing, that's the kind of, we're putting the norms, the processes, the behaviors, the ways of talking and interacting are what enable these teams to be 10,000 feet tall. Okay, so let me show you some data, because one of the things people always ask is like, is this just like, people saying diversity is good? What does it really look like? So first, let's look at teams versus individuals. And again, this is kind of an unbelievable data in terms of scope. So this is every paper ever published. So you get 24 million papers, and you ask, what's the likelihood of writing a paper with more than 100 citations? So that's sort of a cutoff. If Herbert or I is asked to look at a 10-year case, we'll kind of like, okay, how many papers has the person written? How many papers have been cited around 100 times or more? Because that's kind of a proxy for, is it a good paper? What you see, whether you look in science and engineering or social sciences, teams are 4 times as likely to write those papers as individuals. So this is kind of the super additive thing. Teams are better, 4 times better is a lot better, right? If you look within subdisciplines, you'll see that teams win in almost every single subdiscipline as well. So this isn't just happening because of a handful of papers in one area, like physics or something. In almost every discipline, it's true. And in the cases where the individual authors kind of do better, those tend to be disciplines where there's survey papers written by individuals that get a lot of citations. So as a general rule, teams win. If you unpack it, what is it about teams? And again, this is looking not a small study involving 30 people. This is, again, the full 24 million papers. This is work by Brian Uzi and colleagues at Northwestern. What you find is that it's talent and diversity. So the best teams have talented people, but what they find is atypical combinations matter. So what matters is if I'm a neuroscientist and Herbert's a biologist and we write a paper together, we're going to cite papers in neuroscience and papers in biology. Or in this case, he's an electrical engineer, I'm an economist. If we cite papers from electrical engineering and economics, that's going to be an atypical combination. And so what you find is those atypical combinations are what drive successful research. So it's talent plus diversity. Now, you can go deeper, and I think this is where it gets really fun, and you find that like small diverse teams, so maybe Herbert, Sarah, and I, groups of like 3 people, come up with these really disruptive ideas. So if you look at the green line, that's like looking at sort of how disruptive is something as a function of team size. And this is 24 million articles, 2.5 million patents, 26,000 GitHub projects. But then if you look at papers that really develop those ideas, right? So if you come up with sort of like CRISPR being an example, right? That was super useful in developing new vaccines. This is a new idea. That's a handful of people. But then when we see how to use CRISPR to develop new RNA drugs or RNA molecules, then those teams tend to be bigger. So what you see is like small diverse teams disrupt, large diverse teams develop. So it's a more nuanced story than you might think. It's not just diversity good, right? To really have breakthroughs, you need small teams that communicate in deep ways. And we'll get to that more as we go on. Now, if you look at the paper-to-paper sites, patent-to-paper sites, or patent-to-patent sites, one of the things that's really kind of fascinating as well is there's kind of a long play here. And by that, I mean, this is basically looking, the horizontal axis here is the distance and expertise. So this is, again, getting at this kind of like, atypical combination. Is my expertise different than your expertise? And what you're seeing in these different color graphs, the blue is 2-year citation rates, orange is 5-year citation rates, and purple is 10-year citation rates. What you see with 2-author, 3-author, 4-author, and 5-author papers and patents is that if you have a diverse team doing something, as you get more diverse, you're moving to the right in this, you're moving from 0 to 100, the citations really don't start to come for 10 years. You really don't see those benefits until 10 years, because the reason is this isn't the same old. These are actually breakthrough ideas that it takes the academy a long time to digest, right? Or it takes the business world, in the case of patents, a long time to digest to get these benefits. Now, I want to bring up some recent work by Haijun Yoon, who is a student I ran at the summer school at Santa Fe Institute, and she's now a professor at Northwestern, to get at this kind of like importance of DEI 2.0, the importance of sitting down, learning, listening, communicating with people who are different than you. So one of the things that's kind of interesting, if you look at sort of, you can measure learning in our writing as follows. If Sarah and I were to write a paper together, and after we write that paper, I start using terminology or citing papers or using techniques that she has used in her work, we can then kind of infer from my work that I've learned from that collaboration. So if you look at sort of the mean distance between people over time, this is going from 1980 to 2010, you've seen that mean distance has gone way up because we have things like Zoom and things like that, right? And local collaborations has gone down. So we now collaborate with people further away from us, which on the one hand is good because it means that we can collaborate with more people and more diverse people. But if you look I realize these are really complicated graphs, but look at the bigger one that's just sloping down. If you look at kind of the distance in meters on the horizontal axis, on the vertical axis, you're seeing what is the learning rate. And what you see from both these graphs, the one is kind of smooth, the other's not smooth, that as you move further away, you learn less. And the takeaway from this is you need these deep conversations, right? So if Herbert has spent 37 years at Michigan, right, working as an electrical engineer, and I've spent 24 years working as a social scientist, there's really no way we can, just by sending a couple emails back and forth or in a brief Zoom, really understand how the other person thinks. We rely on different categories, different models, different insights. even a concept as simple as uncertainty. So I was presenting to a bunch of people working on interdisciplinary teams sponsored by Vice Provost Lupia. And I said, if I say uncertainty, how many of you think variance? And all the social scientist hands went up. And then I said, how many of you think entropy? And all the engineers' hands went up. So they're actually using different theoretical notions of something as basic as uncertainty. And so in order for those collaborations to work, you've got to speak through those differences. So how then so there's kind of like overwhelming evidence that diversity matters, right? And there's also then overwhelming evidence that diversity's got to be meaningful. But how does it work, right? Well, it's interesting if you say, is it disciplines, right? Or is it terminology? And you look at kind of the novelty percentile. So like, are we using lots of different disciplines or lots of different keywords? And the probability of having one of these hit papers, it turns out that it really is context. It really is these disciplines, which is more evidence for why these diversity 2.0 arguments are so important, because you need these, kind of rich understandings of what people are doing. So this general takeaway is that diversity is necessary, but it's not just any diversity. Diversity produces these benefits through aggregations and through synergies, but you need really careful assemblage. You've got to put teams together the right way, and you've got to interrogate those differences, right? This has to be a deep interaction. It can't be superficial. And so we think about that. What's going on? One of the things I think is so fascinating here is like we like to say, and it's politically correct at the moment to sort of say that diverse teams do better, but that can't be a magical thing, right? There's no magic in science. There has to be a logic. And so what I've been trying to do, and I don't want to overstate my contributions here in any way. There's a whole set of people working in this area of kind of collective intelligence and diversity, just like that first paper I showed you, trying to understand what is the logic? How is it when we're predicting, problem solving, creating, truthing, designing? Why does diversity make us better? So what I'm going to do in the next 10 minutes is kind of walk through some of the logic as to why that's true. So let's start with problem solving. So let's suppose I've got a difficult problem. So it's high dimensional, lots of peaks. I put together a bunch of capable, diverse problem solvers that I can choose from. Michigan's engineering faculty, Carnegie Mellon's engineering faculty, Michigan's arts and sciences faculty. And I'm going to put together a moderately large team. So I'm going to give you two theorems. The first theorem says that a randomly selected competent team will beat the team of kind of the best individuals, where best here is defined by how they do on the problem on their own, right? So I give people the problem, I say, okay, who did best on this? I take the very best people, I compare them to a randomly selected team. The randomly selected team, and again, these are mathematical and computational models, they basically show the randomly selected team should do better. Why? Well, we have to move away from how we think about what people are, right? So if you have this kind of ability view, like what's your SAT score? How good you do in the problem? I'm creating this alpha group of people who score really high, and then this diverse group, some of whom score high, but some of whom don't do that well on the problem. And so you would think from this perspective, oh, choose the alpha group, right? Because these people all score highly. This other group includes people who don't score highly. But there's another sort of way to think about it, and that's like a toolbox view. And so you can think of like, I've got, what tools are people bringing? Are you an engineer? Are you a biologist? Are you a clinician? Someone who knows about the world? And now you can think the alpha group is a bunch of people who've got these tools, tool A, tool B, tool C, tool D, tool E, that are really good on that problem, but they don't have any other tools. Whereas the diverse group, among them, they've got all the same tools as the alpha group, but then they've got additional tools. Now let's go back to the empirical research we talked about before. It's these atypical combinations that give you the really incredible teams. So I've got this IL person down here, and I apologize if you're from Illinois. I'm not being derogatory to those people from Illinois, but the IL person could be someone who's maybe trained in neuroscience, and this could be, or sociology. And if this were in my field of economics, they would not belong to the alpha group, because you wouldn't want a neuroscientist or someone who studies, urban sociology to be the person setting interest rates, let's say, right? But once I've already got 5 people in the room who are trained as economists, adding that person in is going to have huge value, because they may have some insight in terms of how people think, or they may have some insight in terms of what's going on in cities that help the rest of the group think differently. And so you want to think in terms of tools, not in terms of measuring sticks when you're putting groups together. Now, a second theorem is that if I've got a complex task, there's no test applied to individuals that can produce the optimal teams. And there's two versions of this, one by John Kleinberg and Maithra Raghu in 2016, and then one by Lu Hong and I think this came out in December. And it basically says this: if I'm trying to solve something really hard and I've got 100 applicants, there is no test that I could apply to the applicants, right, such that I would then want to choose the 10 highest scorers to get the best team. Now, let's go back to how I started this talk. If it's a simple problem, like if we're running a 4x100 meter relay, there is a test. I line people up, I choose the 4 fastest people. But if it's a complex task, there is no test, okay? And let's kind of see why. Like, let's suppose I'm trying to like figure out obesity. This is a map from the Foresight Group in England of all the different causes of obesity. And what you see is there's all these different disciplines. Like if I scroll down, there's all these different disciplines. So if I gave a test, like who knows the most about obesity, I just get some people who have general knowledge. But what I'd like to have is people who've got like really deep knowledge in all of these subdisciplines. And that's going to allow the group to be far, far better than an individual. Okay, now let's look at predicting. So in problem solving, what we want is we want people to have different tools, right? Trained in different disciplines. That's absolutely crucial. Now let's look at predicting or forecasting. So let's start with a famous example. This is the 1906 West of England Fat Stock and Poultry Exhibition. 787 people guessed the weight of a steer. Their average guess is 1197. The steer weighs 1198. Now, this example is trotted out a lot as an example of the wisdom of crowds, but what's very important to remember here is this is an anecdote. This is just an example, right? So there's cases where crowds are right. There's cases where crowds are wrong. This is a case where crowds are right. Now, our basic impression, most of us think, you know, most of the time, though, crowds are probably better than individuals. That's why we have juries decide guilt and innocence, right? That's why we have a democracy. We like to think sort of crowds are better, but we don't want that to be blind faith, right? We want that to be logic. And there's a very simple logic called the diversity prediction theorem, which explains why crowds are better. And it sort of goes as follows. The crowd's error, and I apologize, this looks like a complicated expression, it's not. C is the crowd's predictions, that's 1198. Theta is the 1197, the actual weight of the steer. I'm sorry, the crowd's predictions was 1197. Theta, which is the weight of the steer, is 1198. So that was the pound. The next term is just the average error of the people in the crowd. And then the last term is the diversity, the differences in their prediction. And so if you plug that in the Galton steer case, the crowd was off by 1.4 pounds. Those are squared errors. That's why we get 2. Each person in that crowd was off by about 70. 70 squared would be 4,900. The reason the crowd was also diverse. So the reason the crowd is so much better is some people's predictions were high, some people's predictions were low, so that diversity sort of cancels out. Now, this is a very simple formula, but it's got a powerful implication that links us back to complexity. One definition of complexity is hard to predict. One definition of easy is easy to predict. If something's easy to predict, the average error is going to be really, really small. So you don't need a crowd, because if you just pick somebody out, they're going to get it right. If something's complex, by definition, it's going to be hard to predict. So the average error would be big. So the only way the crowd could be right if the average error is going to be big is if the crowd is diverse. Now, what do we mean by diverse here? Right? We don't mean different tools. What we mean is different models. We mean different perspectives. So I mean, people have framed things in different ways, like they've lumped the world differently. So now, if we think about people having different life experiences, different identities, reading different books, different training, different educational experiences, they're likely to parse the world differently, and they're likely to draw different sorts of inferences. So different causal models of how the world works is going to give you diversity here. And if the problem is complex, by definition, no one can get it right. And your only real hope then is to have smart people who are diverse to have a small crowd error. So that theorem is always true. So the only question then becomes, how big is this diversity bonus? So here's just one example. This is some work by Jack Soll at Duke with colleagues. 28,000 forecasts by professional economists on 6 leading economic indicators. So unemployment, growth, inflation, that sort of stuff. If you look at the graph, what you're seeing here is the one here is let's benchmark the average error of an economist in this sample set to be 1. The purple line is take the very best economist. So the very best economist is 10% better than a random economist. That kind of red line, if we follow it down, basically says if we just take 4 random economists, we do 14% better, right? So you're moving across the horizontal axis, you're just increasing the number of economists. So what this is telling us is if we get to like 8, 9, 10 economists, we do 20% better. Why is that? Well, it's because each of these economists has a different model, right? So they have different models of how the world works, and that diversity is enabling the collection to be better than the individual. Now, we might not even know who the best one is, right? But the important thing is that, again, this is kind of working against that notion that, oh, we want the best person. What we don't want is the best person, is we want really smart people that are diverse in teams, because teams will do better than individuals once something is complex. So this is just showing that diversity prediction theorem kind of in action on something a little bit more important than guessing the weight of a cow. Same is true with surgeons. So this is using a scoring method as opposed to distance. So higher is better. And this is similar kind of MD Anderson. These are the accuracy of 5 individual doctors. So the best doctor gets a score of 10.2. But when I take the crowd of 5 and have them vote, I get a score of 14. So what you get in this situation is this kind of, again, this kind of result that says, I'd really rather have a team than have an individual once the problem is hard. Okay. Let me push this one step further, and then we'll talk about kind of what we can do as groups. This is also true. This is where I want to push this. When we think about all these recent advances in AI, now there's a bunch of papers in this space. This happens to be one, and this happens to be one that kind of powerfully shows the logic that we've had before. There's others that maybe don't show this large of an effect size. So I want to be careful here. This is just a particular study. But this is a classification study, and what you're seeing here is accuracy is on the horizontal axis. So that little red dot at the top is what is the accuracy of a single human? And then the red dot a little bit to the right of it is what's the accuracy of like 2 humans? So again, 2 heads are better than 1 in these cases because of the fact that you've got this diversity when you're classifying things. So it's like prediction. The top few blue lines there, those are individual algorithms. And then the lower blue lines are pairs of algorithms. And what you see is that, like, again, pairs of algorithms are better than individual algorithms, but on this particular type of task, humans are better than algorithms. Now, the green dots are human algorithm pairs, hybrids. The human algorithm pairs are more accurate than the humans, even though humans are more accurate than algorithms. To explain why that's the case, look at the figure on the other side. This is showing the correlation in how you classify things, right? So higher correlation means we classify things in similar ways. What you see when you look at the algorithms, those are the blue dots, their correlations are really high, and the errors on those are small because they think kind of the same ways. The red line is the correlation of humans, and what you see there is it's all over the map, right? It looks like a snake. So there's some pairs of humans that are really highly correlated, almost 1. So they're seeing the world in the exact same way. And there's some that are kind of negatively correlated, right? But what you see is that the mean of how correlated humans are is pretty close to the mean of how correlated algorithms are. But if you look at pairs of humans and algorithms, that's the green area, what you see is they're much more negatively correlated. What is that saying? That's saying that humans see the world differently than computers. Well, no kidding, right? So I'm teaching this class I'm teaching, one thing we talk about is how do humans classify? Sometimes we use exemplars, sometimes we use prototypes. Oftentimes we use feature spaces, right? So we look instead of like, is this a chair or a couch? Like we're like, okay, how wide is it, right? And then we say, that's a chair, that's a couch. How do computers categorize things? Well, they bring in tons and tons of data. So they have large variable sets. And then they do these dimensional reductions, and then they project onto those dimensional reductions. So they're also using a few variables, but their few variables are high dimensional projections. So there's no way those aren't really different than what we do. And that gives us this negative correlation. Go back over to the other graph. The negative correlation makes humans plus computers better than humans and better than computers. But again, this is of this same piece, and it's kind of proving the logic in a different way or demonstrating the logic in a different way. Should be careful that if we parse the world differently, if we use different categories, if we see things differently, and this is definitely true of people from different cultures, right? People from different cultures even see colors differently. Like we break up the Roy G. Biv spectrum in different ways. We're going to collectively be able to make better forecasts and better predictions. Okay, so what do we do? What actions do we take? This is a lot of science and a lot of evidence, but what do we do from an action standpoint? So why do we have diversity 1.0? Why do we have diversity 2.0? And let me give some just basic takeaways here. So the first thing is, all the evidence suggests kind of two things. One is you absolutely need diverse talent. You have to have diverse talent in the room. Two, you have to have the right structures, processes, and cultures to leverage that talent. So there is no right way to leverage talent, right? Different groups of people working on different tasks, right? It may be that sometimes the structures are highly formalized and hierarchical. Some of them could be market-based. Some of them could be done like clans. Some of them could be done in ad hoc teams, right? There isn't necessarily any run correct institutional form or set of rules or processes. But what you want to have to think about is, how do we make it so we can tap into that talent and make people feel both fulfilled and also make the team perform well? So in terms of getting the diverse talent in the room, this is, comes down to hiring criteria. You have to widen the scope of where you look, and you have to also revisit criteria that you thought of as required. This does not mean get rid of standards or anything like that, nothing of that sort. But what it means is to ask, are there filters we're using to say you have to know this? You need physics to be a doctor or something, right? Do you need those things? Or was that something that somehow just got passed in at some point and it's really not relevant given the nature of the job or given the nature of what we're doing, doesn't require that? Second thing, when you're building teams, you want to think about not necessarily just adding people who have direct knowledge in that field, but you want people who have adjacent knowledge, because that gives you the best chance of getting those kind of atypical combinations. And then the third thing, and I think this was maybe the hardest, when you're promoting someone to become the next dean, department chair, associate provost, whatever, there's a natural tendency to kind of want to replace yourself with someone like you. So it's kind of the just like me effect. But the thing is, that's exactly what you don't want to do. You want to replace yourself with someone kind of not like you, because you've moved things in this direction. And so all of the kind of like your skills, ways of thinking, and the amazing things that you've done to make the university better you're probably stuck in a lot of places. If you hire someone just like you, they're going to be stuck in those same places. Real innovation is going to come if you hire someone different from you. Now, next thing, in terms of how do you really kind of make it work? Increasingly, the evidence is that this notion, and this is kind of, again, coherent with the idea of diversity 2.0, is how do you create this culture of inclusion where where people are happy to be at work, people are benefiting from those diverse interactions. And I'm going to give two views of this. One is kind of the Kim Scott, this is kind of the Silicon Valley business view. And she said there's really two dimensions. You have to care about people and you have to challenge people. So if you care about people, but you're not challenging them, you're in this ruinous empathy box. Like, thank you for sharing that so much. That was so fabulous. But you're actually not giving anybody any feedback to get better, right? If, on the other hand, you're really challenging people and you're saying, that needs to be better. I see a mistake here. This needs to be improved, but you're not caring about them anyway. You're in this obnoxious aggression box. The box she says you want to be in is this radical candor box, where on the one hand, you're challenging people, but on the other hand, you deeply care about them. Now, the academic version of this, which is less kind of catchy, is due to Amy Edmondson, who's currently ranked as the #1 business consultant in the world by a bunch of sources. And Amy's very, very good. And she says, look, rather than care, let's think about this in terms of what people would say safety, right? I mean, do I feel like I'm safe saying what I want to say, right? Which is different from care, and I think probably more accurate here, right? Like, when I'm in the room, do I feel like, hey, I can share this idea? Because if I don't share the idea and I keep it inside myself, no one can possibly benefit for it. Then the second thing is, like, am I motivated and am I accountable for what I do, right? So do I really feel like I want to contribute? And if I do contribute, does it matter that I contribute? And she says, look, there you're in the learning zone. if you're not motivating and making people accountable, her analog of the ruinous empathy box is the comfort zone. I'm just skating along. I'm adding, to the mix, and that, oh, isn't this a nice place that's diverse? But not great things are not happening. Great things require not just safety and care, but motivation and challenge. But if you motivate and challenge and make accountable without promoting that safety, and this is why the school and the college and the university are pushing this kind of 2.0, then you end up in the anxiety zone, right? And so you've got to balance these two. Now, here's where this is where the art comes in. Candor varies by context. There's a great piece, I tweeted it out yesterday, if you follow me on Twitter, by Erin Meyer that came out in 2023. She's at INSEAD, and she talks about when diversity needs feedback. Let's just talk about a very specific thing, and then we'll open it up for questions. How do you give feedback to people different from yourself? Like, it's really easy in a homogeneous group. Like, I moved over to the management school a couple of years ago because I realized for my research and for my understanding of how to, create diverse teams well, make the world better through diversity in some ways, I had to have a deeper understanding of management. Management's hard, and management's harder in diverse teams. So if anyone spent any time in the Netherlands, Dutch culture is kind of fascinating in that it's very direct. So like the very first time I gave a talk in the Netherlands, it was to a fairly large audience. I walked off the stage and I thought, that went pretty well. And my host turned to me and she said, your presentation lacked organizational structure. She didn't say, hey, that was great, way to go. I mean, she literally just had a list of 3 things that I had done terribly wrong. And in Dutch culture, that's considered appropriate. And in American culture, it's not, right? In American culture, we kind of have this, this action sandwich where you might say, hey, that was a great presentation, make people feel good. And then in the middle, we'd say the action. Maybe you should use fewer words. Like maybe you should spell sandwich correctly even, right? And then you would say, well done. Now, there's some evidence that the action sandwich doesn't work that well. And there's a whole set of people for whom it won't work that well because they feel like you're patronizing them in some way. And then let's think about a third case where I got some sort of direct report, right? So I've got someone who's lower status within the university for me. Maybe it's a student, right? Maybe they give a presentation and there it could be that the right thing to do is wait for them like a couple days afterwards when they've kind of settled down, when they're less emotional, and they say, hey, could you give me some feedback on my presentation? And at that point I say, I would love to. And it's in a much more conversational mode, right? So candor is going to vary by context. Now, there's a flip side of that though. And I think this is really important, and Erin doesn't talk about it in an article. And that is receiving with grace. So when you think about when someone's giving you feedback on your work, on your presentation, on a comment you've made, on even like kind of how you're managing your time, anything like that, they may say it in a way that makes you feel uncomfortable, right? They could be too direct, or they could sandwich it in a way and you could feel patronized. There could be all sorts of reasons why, that's just not the way you like to receive, I think, advice, well-intentioned advice. And I think it's incumbent on all of us to sort of say, what? This person's trying. This person wouldn't be giving me advice if they didn't want me to be better. And since they're trying to make me better, yeah, okay, maybe they didn't say it to me the way I'd like it to be said, but they are caring about me and they do want me to improve. And so I will receive this with grace. And then maybe as that conversation, maybe as that relationship builds, I could say to them, Herbert, it's fantastic, but I can take it. Don't need to sandwich this stuff. When I hand you something, just say, look, Scott, fix these 3 things. And I'll be like, fantastic, let's go, right? But that's, again, the relationship has to build. But there's 2 sides of candor, right? There's giving with candor and there's receiving with candor. And all of us are trying to work across our sort of cultural and personality differences to make those communications effective. And if we can do that, that's how we stand the chance of tapping into our diversity to get down that long tail. Okay, so kind of, last takeaways here. When you think about processes, it's very important that people have the time and the resources to think, because the diversity, it has to have time to kind of like stew and think and reason, right? people have to have the opportunities and channels through which to communicate once they've had the time to think. And the third thing is you really do have to align these diversity efforts with mission. So, bringing in someone who's diverse, whether it's due to identity, whether it's due to experiences, whether it's due to training, whether it's due to background, whatever it is, if that diversity isn't aligned or adjacent to the mission, it's just not likely to be correlated with that team doing better, right? Because it's just kind of like, almost like diversity for the sake of diversity, as opposed to diversity for the sake of improving the mission. And so by improving processes, and also in a formal way, and that doesn't mean making processes bureaucratic. It can often mean the exact opposite. I think at the University of Michigan, to be blunt, I think we often over-bureaucratize some of these things. You also then, whatever the process is, you have to think about how do we develop the art of candor, right? Both in giving and receiving, in order to tap into our skills. So again, just to kind of put my ending at my beginning, every day working in this space, I see a new paper that has something along the lines of, wow, diversity is really powerful on these complex tasks. It's this type of diversity on this task. Here's how people should be networked. Here's how you could tap it in. Here's how big the team should be. It's an undeniable scientific fact with just ridiculous amounts of evidence that the best teams are diverse. It's also an undeniable scientific fact that at the current moment, some of the worst teams are diverse. And that's because they don't have structure, they don't have process, they don't have culture. Our obligation, our responsibility, right, is in this kind of like, green eggs and ham place. This is always true. It's true for all the complex problems we face. It's true on a graph, it's true on a tree, it's true for the SDGs, it's true for dealing with the environment, it's true for nuclear power. All these challenges that we're facing, diversity is better, can be better, if we get the other part right. And so I'm just going to end with a quote by Wendell Berry, is that we have to kind of change how we are. This is, I think, the hard part. And I think oftentimes we're thinking about what's good for us as opposed to what's good for the world. And I think in this case, what's good for the world is good for us, right? I think we all accept normatively what's good for the world is that we're a more inclusive society. But it turns out that being a more inclusive society is also very much in our own self-interest. So there's not just the normative angle, which is clearly there. There really is, in the mission of this university, of which there are many, on the research side, on the service side, on the community side, figuring out how to be inclusively productive, caring, and challenging is just going to make us a better university. Thank you very, very much. I'll try and stop sharing here. Got it. Thanks.
Yeah. Thank you, Scott. Thank you. And I'll be absolutely candid. That was an amazing talk. Very enlightening. Thank you. So now we're going to open it up for questions. The Q&A button is live now. You can put your questions in the Q&A. But I'm going to lead off with some questions that were pre-submitted. The first question I have for you is that diverse teams are the best and the worst at the same time.
Right.
What are some common pitfalls you notice in diverse collaborative work, and what do you do to mitigate them?
Yeah, so one of the things I think is fascinating is like my chair here at Michigan is named after John Seeley Brown, who ran, who's got his PhD from Michigan, but he worked in Silicon Valley building diverse teams. And one of the things that I'm coming around to having a better appreciation for is even things like the value of having like physical artifacts or having some sort of like dashboard or understanding of where the problem is. Because one of the things I'm teaching in my collective intelligence class, which is kind of fascinating, is that if we all see the world in the same way, that's great because then we can communicate quickly. But it's bad in the sense that then we're all seeing it the same way, we're all stuck at the same spots. And so if you can figure out a way to leverage your diverse ways of seeing, right, you can do really, really well, right? If you can't, then you can do really, really badly. It's like these alignment problems people talk about in AI, where someone tells you to do something and then you go do it, and it's just been a complete misunderstanding, or you're kind of climbing different hills. So if you think of problem solving, we often model that as like climbing a rugged landscape. Well, if your landscape's different than mine, we're kind of going at cross purposes. So I think that there's this paradox of seeing the world differently, right? That if we can figure out a way to leverage our seeing the world differently as opposed to be compromised by it, then we're a good team. If we don't, we end up being a bad team. It's also the case that things like trust are kind of harder to, I think, create among people who are don't come from the same background, and I think that can make the diverse teams not do as well.
Okay. So what are some of the most effective ways a team can ensure that all voices are heard? In the talk, you mentioned radical candor and how that's difficult to achieve. How do you make that work with groups of faculty and staff, and perhaps most importantly, student project groups?
Yeah, so I think this is a real challenge, right? So I think there's places like Amazon now that have done things like gotten rid of PowerPoints, and they make it so everything's a 5-page written statement, and then everybody has to then check out a room, put on their calendar when they're reading the document. So I think step one is you've got to make sure everybody has the time and opportunity to kind of like be informed and be ready to contribute. Because I think one of the things that happens is, and this is especially true of students, that some of them just are so busy, and all of a sudden it's like they show up at their team meeting, and I'm not trying to be disparaging of our students, to the opposite. They're just doing so much that then they're like, oh yeah, now I've got this and I haven't had any time to prepare, right? So the first thing is people have to have the time to prepare so they actually have something to share, right? So they, because I think that's one of the big problems. I hear this from students all the time. It's like, oh my gosh, I'm in a group and like 3 people didn't do any work beforehand, right? And so you've got to get people to try and come in with some level of quality. Second thing is then you have to think about, do we have some sort of process in play where people are sharing, somewhat equally, right? So, again, there's evidence in a group that one person might talk 70% of the time if there's only 4 people in the group, and 2 people will talk 60% of the time if there's 7 people in the group, that sort of thing. So you want to have a process by which you say, okay, everybody spent 4 minutes telling us, what you think, right? The advantage of doing something like that is then it works back to the first part, which everybody knows, like, wow, I've got to do my homework. Otherwise, my 5 minutes are going to be bad, right? And so I think with the student groups, one of the things that's very important, and I talk to my sons about this a lot as well, is what can go wrong is like you go to that first meeting and like, I've had more time, I'm more interested, and my other teammates aren't, and I'm worried about my grade, so I'm just going to kind of do it myself, right? As opposed to saying, let's all make sure we have time, and let's get everybody's ideas out there, and then let's allocate things and make sure we get things done, right? So I think that the equal speaking and opportunity to prepare are super crucial for the student teams. And also one of the things is getting past the insecurity stuff. People are often super insecure, right? And that can cause them to say too much or say too little in those settings.
So clearly students would benefit from having training in team work.
Oh yeah. No, this is one reason, like this is what's so funny. You can't read I'm a huge fan of the humanities, right? But you can't read the Odyssey and then like run a ship. You actually need some training, right? No, so we do this like with our MBAs. We do, teaching this management course. We have them do this team challenge thing, and they're not that good at it. Then we teach them just some basics of how to work in a team, and they do another one that's harder, and it works better. So like even one simple thing is like sitting down and as a first step, agreeing on what your process is. Like, how are we going to work as a team? Like having a meeting about that is hugely beneficial. And you'll have people say, wow, that never occurred to me. And it's like, wait, and a lot of these people like played sports or played music, or something, right? Or they're in a play. It's like, but it just never occurs to them that the same logic applies to like their student projects. right? You need a plan for how you're going to attack the task.
Okay. Right. Now I'm going to move to one of the live questions from the audience. And it says, the diversity you're talking about is skills, perspectives, values, and demographics related,
Yeah.
such as gender, age, and race and background. Do we need to rethink how we think about and measure diversity?
Yeah, I mean, I think we have to, I don't know if we have to rethink, but I think we do have to like think about it, right? And this is the magic sort of stuff, right? So you want to think, I guess, let's just first take the pragmatically, like suppose we're trying to figure out how do we deal with, the 17 UN Sustainable Development Goals, right? Then you want to think about, okay, what are the relevant types of diversity? And like, so yes, training matters. Even two, mechanical engineers who went to different colleges are going to have learned different things, right? Age matters in terms of life experience a lot, right? Identity matters in terms of not only kind of how you go at problems, and this is when I talked about like when you're replacing yourself as a dean or department chair, but there's something that people call like the problem of problems, or I like to call the Mary Oliver question, which is, what are you going to do with your one wild and precious life? Right? She asked this famously in this poem. And when you and I think about what we're going to do with our wild and precious life, those are going to be different things, right? Each person's going to have a different set of things that really matter to them. And so when you give different people kind of the keys to the car and they get to decide a little bit which direction to drive it, people from different identity groups, different backgrounds, different cultures, different experiences are going to kind of point that car in a different way. And so I think that this is just my impressionistic account, is that identity matters a lot on the problem of problems. Where are we channeling our energy? But it also matters on how we think about solutions to problems, where we've been trained in terms of, and how we think about stuff. But then the evidence shows, again, if you look at 15 million papers, 16 million papers on does gender, does race matter? It turns out gender, race, and being at a different university all give like 5% bonuses. So it's kind of like, but that's not surprising. Like, let's just take your department, right? If you went to the seminars at Ohio State or University of Chicago or Berkeley, they're reading different papers. They have different people through. They're hanging out with different colleagues. Their mind is just filled with different things than yours just because of where they at, right? And if you take someone from a different racial group or cultural group or different gender, right, they're also just experiencing different stuff. And so, yeah, you look across a couple million papers, it's giving you 2-3%. Now it's funny when you talk to like people in the academy, they're like 2-3%, whatever. You talk to people in like finance, 2-3% makes them jump up and down, right? Or people designing computer chips, or people designing in the medical field, right? Saving 3% more lives is a pretty good thing, right?
Okay, right. So another question from the live audience. When we have political or social responses to diversity, how can we, no, let's see, how can we reframe it so that we are more resilient to that pushback? Okay, so
Yeah, I mean, so
it
there's,
says,
yeah, let me try. Hopefully I'll answer this correctly. I mean, in the answer the correct question. I think one thing when you think about, there's a lot of kind of like political diversity in terms of how we think about how the world works, right? And my wife, who's a political scientist, would say it's very important to distinguish between kind of like diversity in terms of what we really want the world to be like versus diversity over kind of the policies we think that will achieve that, right? So no one's running for president saying, I want lots of crime, I want lots of unemployment, I want low growth, I want to destroy the environment, right? But there's some people who think the way to do that is through more government, and there's other people who think the way to do that is to kind of do less government, right? And so there's policy questions, right? Like what's the best policy? I think like these small scale nuclear reactors are a great example, right? I know people who, I think everybody wants, cleaner energy, and I know people want both sides of that. And those are deep, difficult discussions. And I think if you don't go deep, you can be like this. But if you go deep, you can be like that. And then you can say, Herbert and I disagree. But the thing is that, he's got a reasonable opinion, I've got a reasonable opinion. And as more evidence comes in, Keynes famously said, when the facts change, my ideas change. I think one of the things that's going on in America, unfortunately, now is that we're in these factions and the facts change and our ideas don't change. And I think that is true of the all-knowing professors on the left in universities. And I think that's true of, the people on the right, not some of them not in universities, right? I think there's a lot of factual reality that's not in line with a very, sort of simplistic political ideology, right? It's a complex world, right? And there's places where markets are spectacular. There's places where central planning is spectacular. There's places where algorithms are spectacular, but and I think the challenge is we should be sorting that out.
Right. Now, another question that was pre-submitted. It says, you presented a lot of data.
Right.
What do critics say? Is there selection bias?
Yeah, so I'm a theorist, right? So so the data I put up is other people's data, most of the time, right? And so the data here is really fascinating to me because it is the case when you look at like diverse teams. It could be that there's a lot of diverse teams that are, and there's evidence that a lot of diverse teams aren't very good. And so when you look at and you run a regression, like do diverse teams do better? The answer is yes, but maybe you're only seeing the ones that actually got the paper out, right? And so I look at this data and I sort of think that like, wow, if we were better, there's the homogeneous teams, I think almost all the stuff they're producing, we're seeing, right? But I guess when I look at this, I think that things are probably even better than the data would show. So the metaphor I always give here is, if I took a bunch of 6-year-olds and said, what's better, riding a bike or running? And had them go as far as they could in 10 seconds. The people running would give a nice normal distribution, right? With the mean of about 50 meters, and some kids go 60, some kids go 40. The bike data would look like the team data, right? There'd be some kids who know how to ride bikes. They'd be way down there. And then there would be carnage on the left-hand side of the kids who can't ride bikes. And that's what the team data looks like. And so I think there is selection bias on the bad. We're missing more of the bad teams, which makes it even more incumbent upon us to think about, how do we get this to work? I'm also a little worried, like Hygen's paper. The reason I put that stuff in on remote versus in person is I think we do have to really learn how to better interact across difference remotely, if we want to reach our full potential, or we got to figure out ways to be in person a little bit more and be very, very deliberate about what kind of people we're hiring if it takes these deep conversations.
Mm-hmm. Hey, well, on that note, I think our time is about run out. And so I'd like to thank you very much, Scott, for this wonderful, wonderful presentation and discussion. We appreciate you taking the time to join us today to talk and think about this very important topic. Now, we'll be sending the audience a brief survey to collect your feedback on today's lecture, and we'll drop the survey into the chat as well. So thanks again for attending today, and have a wonderful day.
Thanks, Herbert.